In the next 20 years, humanity could take its boldest leap ever, not just landing on the moon again, but launching crewed missions far beyond, to Mars, and even farther, to Ceres, a world rich with secrets at the edge of the asteroid belt. The linchpin for these dreams? A controversial, multi-billion-dollar space station hovering in lunar orbit, the Lunar Gateway. But is this orbiting outpost the vital springboard we need, or a costly dead end that could sink the next era of space exploration? As rival nations and private companies race skyward, what's at stake isn't just scientific glory, but the future of money, technology, and opportunity in outer space. And tonight, the stakes and the questions have never been higher. Imagine a sprawling, high-tech laboratory circling the moon, part science fiction, part geopolitical chess piece. The Lunar Gateway is not just another space station. It could be the launch pad for humanity's greatest adventures. But its complex web of international partners, ballooning budgets, and fierce critics raise a question. Will the Gateway propel us to Mars and Ceres, or become the most expensive white elephant in orbit? Let's break down the vision. The Lunar Gateway is being assembled piece by piece through an unprecedented coalition: NASA, the European Space Agency, Japan, Canada, and even the United Arab Emirates. The first two modules, the power and propulsion element and the habitation and logistics outpost, are currently in the final stages of preparation. Welding for the Halo module finished just this year, and the fuel tanks for the Gateway's propulsion system are ready for their stress test gauntlet. Artemis 4, the historic uncrewed launch, is slated for no later than December 2027. 4 more crewed missions will follow by the early 2030s. This is no mere duplicate of the International Space Station. The Gateway is designed to survive the moon's harsh radiation, act as a cutting-edge communications relay, and support lunar landings, multi-week research missions, and, crucially, test the systems we'll need for truly deep space journeys. The ISS, for all its triumphs, never ventured beyond low Earth orbit. The Gateway offers a jumping-off point into the great cosmic unknown. But why not just go to Mars directly? Why detour through lunar orbit? That's where the real debate begins. Proponents argue the Gateway will allow us to develop, test, and perfect technology in deep space conditions, deal with challenges like extreme radiation and microgravity, and master the logistics of long-duration human spaceflight. It's a rehearsal stage, a maintenance hub, and a crucial safety net, far from the comforts of Earth. Malaya Kumar Biswal, CEO of Acceleron Aerospace, says, "Advancing the Lunar Gateway to support multiplanetary missions represents a bold step forward in human space exploration. This approach optimizes resources by combining multiple destinations into a single mission and creates sustainable infrastructure for ongoing deep space exploration." Others are not convinced. As Michael Griffin, former NASA administrator, put it bluntly, "A lunar orbital platform makes no sense if you want to go to Mars." Critics say every dollar in year spent on Gateway is a dollar in year not spent on direct Mars hardware. And with budgets tightening and new players entering the space race, those resources are limited. It's a classic conflict. Invest now in long-term infrastructure, or focus relentlessly on the immediate goal. On the ground, the technical details are staggering. The Gateway will be the first to host electric propulsion thrusters, advanced engines that sip fuel and promise to slash costs for deep space travel. ESA is developing high-speed communications networks to link the Gateway, the Moon, and Earth in real time. New radiation shielding tech, using hydrogen and boron-rich materials, will be put to the ultimate test, protecting future crews from cosmic rays that can shred DNA, erode memory, and trigger potentially catastrophic health crises far from help. In fact, 3 major radiation studies are scheduled as part of the Gateway's first science payloads. It's not just about technology. The Gateway is a symbol of international cooperation in an age of rising tensions. As NASA's John Olenson says, building and testing hardware for Gateway is truly an international collaboration. For the first time, partners from North America, Europe, Asia, and the Middle East are pooling resources, expertise, and prestige. But with so many cooks in the kitchen, can the project actually deliver? Meanwhile, the ambitions keep growing. Concepts circulating among planners are eyeing the Gateway not just for moon landings, but for daring missions to Mars and Ceres. One mission outline looks like something straight from science fiction. Astronauts launch from Earth, dock at the Gateway, travel to Mars for orbital and surface exploration, then leap onward to Ceres, the largest object in the asteroid belt, before returning home. A journey of nearly 500 million kilometers, stringing together multiple worlds, all with a single, evolving infrastructure. Why Ceres? Here's where economics meets planetary science. Julie Castillo-Roges, a planetary scientist at NASA JPL, points out, Ceres has a crust of about 25 miles of water-rich material, and about 40% of its volume could be water. In the economics of space, water is the ultimate currency. It can be split into hydrogen and oxygen for rocket fuel, or used directly to sustain life. If humanity wants to colonize the solar system, Ceres could become a crucial refueling depot, and the gateway a toll booth on the highway to new worlds. But this vision faces formidable obstacles. Even as assembly of the gateway's components accelerates, schedules slip and costs rise. The Halo and PPE modules, long-awaited and technologically complex, will need to survive a brutal series of safety and performance tests in the vacuum of space, not just the lab. The Artemis missions themselves have already been delayed multiple times, prompting critics to wonder if the gateway is following the troubled path of earlier megaprojects that spiraled over budget and under-delivered. The radiation environment, so deadly outside the protection of Earth's magnetic field, remains a stubborn hurdle. Astronauts on the gateway and beyond will face unprecedented exposure to galactic cosmic rays. Amir A. Bahadori, a leading space radiation expert, warns, space radiation protection requires justification, limitation, and optimization. The moral and technical challenges here are profound. How much risk are we willing to ask astronauts to accept? How far can new shielding technologies, still unproven in deep space, really go? Propulsion is another battleground. NASA is testing groundbreaking electric thrusters for Gateway's operations, potentially to be installed as early as 2025. But even these advances cannot, by themselves, solve the massive power and energy challenges of sending humans safely to Mars and Ceres. Advocates of nuclear power systems like Biswal stress that fission power systems offer significantly higher and more consistent power output, but public fears and regulatory hurdles persist, and no nuclear-powered deep space mission has ever been attempted with astronauts on board. Meanwhile, powerful private sector interests are reshaping the landscape. SpaceX, Blue Origin, and other commercial players are racing to build their own space stations, including proposals for commercial outposts in lunar orbit. If companies can offer faster, cheaper, or more flexible infrastructure, will national governments keep pouring money into the public gateway? Or could the gateway become an expensive relic, outpaced by the breakneck innovation of private industry? Even the scientific rationale is in flux. Some argue the gateway's modular, flexible architecture allows us to refit and retool as we learn, making it the perfect test bed for new technology. Others warn that every year spent building and maintaining the gateway is a year lost in the dash to Mars or Ceres, where China, Russia, and commercial interests are now racing to stake their claims. The risk isn't just technical or financial, it's falling irreversibly behind in the most important competition of all. Underlying all of this is the ever-present reality. Space is hard, expensive, and unforgiving. The International Space Station has taught us that international collaboration can achieve the extraordinary, but also that budgets run out, alliances shift, and political winds change direction overnight. There is no guarantee the gateway will see its full vision realized. Some analysts predict its modules could serve as the last great monument to multinational space cooperation, a triumph, or a white elephant orbiting in lunar gravity for decades, underused and overfunded. And yet, the science beckons. In tandem with the gateway, NASA is evaluating a sample return mission from Ceres under its New Frontiers program, with a potential launch as soon as 2030. This would be a robotic precursor to the crewed missions imagined for the 2040s. Ceres may hold the keys to understanding the origins of water in our solar system, and perhaps the formation of life itself. As Rafael Ribeiro de Sousa, a planetary scientist, notes, Ceres began forming in an orbit well beyond Saturn, suggesting it's a frozen time capsule of the early solar system. So where does that leave us? A monumental project, championed by global alliances and high technology, which could unlock the next era of exploration, or turn into a bureaucratic albatross, draining resources from more direct, ambitious missions. The technical hurdles, radiation, propulsion, logistics, are huge, but so are the potential payoffs, economic opportunity, technological breakthroughs, even the ultimate prize of becoming a multiplanetary species. As the first hardware prepares for lunar launch and political and commercial interests collide, we're left with a burning question, and it's one that may determine the future of humanity's place in space. Will the Lunar Gateway become the gateway to the solar system's greatest riches and mysteries? Or will it trap us, orbiting endlessly in lunar twilight, as others claim the stars? The answer, and the future of space exploration, hangs in the balance. So now, as we peer into the future, let's open the door to the possible destinies that the Lunar Gateway could carve out, not just for itself, but for all of us who dream beyond the cradle of Earth. The choices, the risks, and the revolutionary opportunities ahead are as vast as the space it will orbit. First, if all goes according to plan, the next few years will see the Gateway's primary modules, Halo and the power and propulsion element, launched and pieced together in the vacuum above the Moon. This orbiting outpost will serve as our first true deep space testbed. The initial uncrewed launches, set for late 2027, will be followed by ambitious Artemis missions bringing crews, new science equipment, and the anticipation of a new era. Imagine, by early 2030s, international astronauts waking up to an Earthrise unlike any seen from the ISS. This will be a platform where new propulsion systems are tested, where life support is pushed to its limits, and where hard-learned lessons protect crews from the relentless assault of cosmic radiation. But this vision comes with high stakes. There's a very real possibility that the Gateway, burdened by cost overruns or shifting politics, never fulfills its promise. Critics like former NASA Administrator Michael Griffin have warned, a lunar orbital platform makes no sense if you want to go to Mars. If delays pile up and budgets dry, the Gateway risks becoming a cautionary tale, a monument to overreach, orbiting the Moon without ever opening the door to Mars or Ceres. Yet the flip side is electrifying. If the Gateway thrives, it will become more than just an outpost. It will be our springboard to the solar system. Studies like the one by Malaya Kumar Biswal and Ramesh Kumar 5 envision a bold, multi-planetary future. Crew launches from Gateway, stop at Mars for exploration, then press onward to the dwarf planet Ceres, our first stepping stone into the asteroid belt. Julie Castillo-Roges from NASA JPL reminds us, Ceres has a crust of about 25 miles of water-rich material, and about 40% of its volume could be water. That's not just scientific curiosity. It's the raw resource for in-space refueling, life support, and possibly even agriculture. One day, tapping into Ceres's water could drive a new era of sustainable exploration, supporting a flotilla of ships venturing deeper into space. Picture this. By 2045, a new mission concept, Earth to Mars, Mars to Ceres, Ceres back to Earth, all staged from the Gateway. Such a mission isn't just science fiction. According to the latest proposals, this would optimize resources and set the architecture for ongoing deep space exploration, potentially flipping the economics of interplanetary travel. Of course, all this hinges on overcoming formidable hazards. Deep space is a cauldron of radiation. Astronauts beyond the shield of Earth's magnetosphere face DNA damage, memory issues, and cancer risks. That's why 3 radiation studies are planned for Gateway, and why engineers are experimenting with novel shielding materials like hydrogen, boron, and nitrogen. Amir Bahadori of Kansas State University bluntly states, space radiation protection requires justification, limitation, and optimization. It's an ethical responsibility as much as a technical challenge. Then there's propulsion. Today's chemical rockets are slow, heavy, and limit how much we can carry. But NASA is now testing an advanced electric propulsion system for Gateway, aiming for installation by 2025. And looking further ahead, experts like Malaya Kumar Biswal argue nuclear propulsion could be the true breakthrough. Fission power systems offer significantly higher and more consistent power output. That could slash travel times to Mars from months down to just weeks, a game changer for crew health and mission flexibility. The possibilities don't end there. If commercial space stations begin populating lunar orbit, we could see a vibrant space economy where governments, private firms, and international partners operate side by side. Lunar Gateway might morph into a bustling intersection in a network of orbital waypoints, supporting not just exploration but also manufacturing, mining, and even tourism. But what if the Gateway falters? What if SpaceX and other new space giants leap ahead with direct Mars missions, rendering Gateway obsolete before it truly begins? The ISS taught us the value of learning in place, but also the pain of watching aging tech outpaced by rapid innovation back home. In a worst-case scenario, Gateway becomes a white elephant, a half-finished relic, circling endlessly, a silent lesson in missed opportunity. So, let's take a closer look at what this means for all of us on Earth. Beyond the headlines and technical debates, why should the Lunar Gateway matter to you? First, it's about ambition. The Gateway is more than a habitat or a lab. It's a symbol of humanity daring to operate further from home than ever before, pushing the limits of collaboration, technology, and our own bodies. Its success or failure will set the tone for how we approach big, complex global projects, whether in space, climate action, or technology on Earth. Second, every breakthrough aboard Gateway has ripple effects back home. The technologies developed to keep astronauts healthy in deep space, airtight recycling, robust remote surgery, next-gen medical monitoring will shape healthcare, recycling, and disaster relief on Earth. The miniaturized, resilient electronics needed for lunar orbit are already finding their way into your smartphones and hospitals. There's also a lesson in risk and resilience. The Gateway is a wager on the future, but so are the challenges we face on Earth, from pandemics to climate change. Seeing how engineers and scientists tackle radiation, isolation, and limited resources in lunar orbit can inspire us to face terrestrial problems with creativity and courage. Perhaps most importantly, the Gateway demands international partnership. As John Olenson from NASA puts it, building and testing hardware for Gateway is truly an international collaboration. In a world where geopolitics often divides us, the Gateway shows what's possible when nations pool their talents for a common vision. The Artemis Accords and the Gateway's crew roster feature names from Europe, Japan, Canada, and the UAE, a living experiment in global trust. But there's a practical takeaway here too. If you're an aspiring engineer, scientist, or even a student dreaming of space, it's time to pay attention. The skills being honed aboard Gateway, robotic assembly, autonomous navigation, remote diagnostics, are exactly what will underpin the next wave of industries, from robotics to AI to energy systems. Even if you never leave the ground, the drive, the curiosity, and the teamwork on show will be the blueprint for your own ambitions. And let's not forget, while the media covers only the headline launches, dozens of unsung innovations are happening every day in Gateway's shadow. Many of the small startups and emerging space companies, testing data links, habitats, or life support subsystems, are open to young talent and big ideas. The Gateway, in more ways than one, is a real-world demonstration that tomorrow's discoveries are being built today by people just like you. So, what is the answer to our initial question? Will the Lunar Gateway become the crucial stepping stone that propels us to Mars, Ceres, and beyond? Or will it be remembered as a costly detour, a deep space cul-de-sac? The truth is, the Gateway's ultimate fate is not yet sealed. Its future will be determined not just by hardware and policy, but by the same spirit that launched the first humans to the moon: resolve, resourcefulness, and a willingness to learn from setbacks. If the momentum holds, Gateway can be the forge where new technologies, strategies, and international partnerships are tempered, laying the foundation for the first true interplanetary missions. But if it falters, the lesson will be clear. When ambition outpaces planning, even the brightest ideas can spiral into irrelevance. It will then serve as a silent teacher, a reminder for the next generation to dream boldly, but build wisely. And here's a secret fact. In the last few years, discussions have quietly begun about turning Ceres into a deep space fuel station, where autonomous robots could mine water ice, convert it into hydrogen and oxygen, and refuel passing spacecraft. If Gateway and its successors pave the way, our solar system could someday have its own network of cosmic pit stops, making journeys to Mars, Ceres, or even Europa routine. So, what do you think? Should human exploration take the slow, careful route, building stepping stones like Gateway? Or should we risk a direct leap to Mars and beyond? Could the Gateway become the next ISS, a hub of science and partnership, or a ghostly orbiting relic? Let us know your thoughts in the comments. If you enjoyed this deep dive into humanity's next great leap, hit like, subscribe, and ring the bell for more epic journeys into the universe's most fascinating frontiers. Your support helps propel us further on our mission to bring you the stories shaping our future in space. And remember, as we write the next chapter of space exploration, the Gateway may very well be the bridge between